Section 5.1 Quadratic Functions Application. Question number 1. A backyard farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She has purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard fence as the 4th side. Find a formula for the area enclosed by the fence if the sides of the fencing perpendicular to the existing fence have a length L. What dimensions should she make her garden to maximize the enclosed area? We need to find a few things here. First of all, the fencing is going to be used just for 3 sides, and she's going to use the 4th side. She's going to use a part of the garden fence, the backyard fencing, as a fencing for the garden. So if this length is L and that is W, this is going to be L as well. And we know that because she purchased 80 feet of wire fencing, if we add all of these lengths together, we will get 80 feet of wire. So we're going to say L plus W should be equal to 80. So 2L plus W should be equal to 80, and I'm going to name this equation number 1. Now, I know that the area is equal to length times width. Now, I would like to write the area in one variable only, either L or W. It is easier for me to take equation number 1 and solve for W from there in terms of L. So I will do that. I will have 2L plus W equals 80. I will subtract 2L from both sides in order to solve for W. So I have W equals 80 minus 2L. I will name this equation number 2. Now, I'll take equation number 2 and plug it instead of the W. So I will take equation number 2 and plug it into the area equation. I will take the W, which is equation number 2, and I will plug it in the area W here. So I will end up with a function for the area that is in one variable, not 2 variables. It's going to be just in the L variable. So I will have the area here is equal to L times 80 minus 2L. All I did, I removed this L, replaced it with its value, which is equation number 2. Now, I can distribute the L inside, so I end up with the area is equal to 80L minus 2L squared. So that is basically the area, which is a function in L. I can even rewrite it as A of L equals to negative 2L squared plus 80L. Notice how this is a quadratic function. So I can find the maximum in this case since A is negative. A value is negative, so I know this is going to look something like this, and we're going to have a maximum. So in order to find the maximum, I'm going to find H and K. K is the maximum, of course, and H is going to be the value of L that is going to provide the maximum value. So I will find H, which is in this case L. This is equal to negative B over 2A. In my case, B is 80 over 2 times negative 2. So that is A. That is equal to negative 80 over negative 4, which is equal to positive 20 feet. And that is basically the length, and it is the H value. So the H value is going to be the length, because that is the variable we're using here in our equation. And then the function itself is going to be the area. So the K value is going to be the area. Now that I found the L, which is basically the length, so these are one of the dimensions. That is the L value. I can find W. I just need to use equation number 2. So I'm going to use equation number 2. To find the width. The width is equal to 80 minus 2 times L, which is, we found it 20. So this is going to be W equals 80 minus 40, which will be 40 feet. So that is the width. I know the concept might be flipped, but that is what we have on here. So W is equal to 40. And now I will be able to find the area. Either you're going to find K value, or you can just basically multiply length times width, and you're going to find the area. So these dimensions are the dimensions that are going to be required in order to maximize the enclosed area. We know that because this represents the maximum of our function. So these two dimensions that we found are the dimensions needed to make the area or maximize the enclosed area. And if we are interested in the area itself, we can basically say the area is either you find K value or you just multiply 20 times 40, which is going to be 800 square feet. So that is basically how you're going to solve these types of equations. Many of these equations are going to ask you to maximize or minimize. So you have to come up with an area function. In this case, an area function, and then the area function is clearly going to yield a maximum. The h of the maximum is going to be the variable in the equation that you use, whether you use W or L. Then you're going to use what you found previously in order to determine the other dimension. If the area is required, that is basically the K value of the vertex. Here is another example. A ball is thrown upwards from the top of a 96-foot high building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation h of t equals negative 16t squared plus 80t plus 96. So here is a scenario. The ball is kicked from the top of the building and it's going to go in a curve, of course. This building is basically a 96 feet building. And then the equation is given by this equation right here. So here is the point, which is basically h and k, and it's going to represent the maximum height of the ball, basically from the ground here. Okay, when does the ball reach the maximum height? The time is basically the variable used here. So t is going to be equivalent to h, and then the k is the height of the function. Always the x value or what it is supposed to be the dependent variable is going to be h, and then the dependent variable or the y value is going to be the k value. So in order to determine the time where the ball reaches the maximum height, we need to find t, which is in this case the h of the vertex. So I'm going to say t, which is the h of the vertex, is equal to negative b over 2a. I know that b is 80, so negative 80 divided by 2 times negative 16, which is the a value. This is equal to negative 80 divided by 2 times negative 16, negative 32, and that will be 2.5 seconds. So the time needed, so number 1, the time needed for the ball to reach a maximum height is 2.5 seconds. So that is the first question. What is the maximum height of the ball? The maximum height of the ball is the k value, which is gonna happen when the maximum, when the time is 2.5 seconds. So to answer question number 2, we're gonna find the k value, which is basically the maximum height. So k is going to be, in this case, h of, it's gonna be h of 2.5, which will be negative 16 times 2.5 squared plus 80 times 2.5 plus 96. I'm going to find that on my calculator. I'm getting k is equal to 196 feet, of course, because the height is in feet. So that is the maximum height the ball will reach. Please verify that answer. And then the last one, number 3. When does the ball hit the ground? The ball is going to hit the ground at this point right here where the height is equal to 0. So where the height is equal to 0, the ball is going to hit the ground. So that is what we're going to do. We're going to replace h of t with 0. So we're going to have 0 equals to negative 16t squared plus 80t plus 96. And then you're going to solve this quadratic function using your favorite method. I would prefer the quadratic function here, the quadratic formula, because the numbers are big. So after solving, I got two answers. T equals -1, which is impossible since the time is negative. And then t is equal to 6 seconds, and that is the most plausible answer. So the answer is 6 seconds. Again, the height here, let me write it down. So the maximum height is 196 feet. And then we found the time needed for the ball to reach a maximum height is 2.5 seconds. So hopefully this application is clear. If you have any questions, please let me know.